Question 3. More microwaves. This time it's Charlie investigating some two-source interference. So this is pretty standard setup. You've seen this a ton of times. It's just that we've got a microwave source rather than a laser. And we're using this aluminium sheet with gaps rather than a sort of close together double slit setup. The pattern won't be visible, so we're using a microwave detector. 5 marks for this. Describe how the intensity varies as she moves the detector along the dotted path and explain what causes the variation. So basically this is a double slit diffraction pattern, and we have to explain the nature of the pattern really. 2 parts to the question: describe and explain. So I'll start with the description. 5 marks is quite a lot. You know, a 6 mark QER you expect to have to put in quite a lot of effort. But this isn't a QER, so what that means is there's definitely 5 points to be made here. It isn't a banded mark scheme. It means that there's going to be 1 mark per point made. So the first thing I'm going to say is that the microwaves are going to diffract out from these slits and therefore spread out. That is, of course, important because if they don't do that, they don't overlap. That in turn means that these slits act as coherent sources. So in terms of, this is more of an explanation to be honest than a description. I said I'd start with the description, I haven't. But this is what's happening. The slits act as coherent sources, therefore the detector records repeated maxima and minima, repeated maximum and minimum intensities. Along the dotted line. Why? Because if we're here at the center point, at center we are equidistant. You don't have to use a word like that, but you can say that the path difference is 0 is what I'm getting at. We are equidistant from slits, so 0 path difference. Hence, constructive interference. As the detector moves along this dotted line, that's not how you spell line, moves along line, path difference changes, something like that, to produce destructive interference. Destructive interference when path difference equals, so lambda over 2 or 3 lambda over 2 or 5 lambda over 2, etc. And constructive interference I suppose I could have written that in some sort of formula. when path difference equals n lambda. I think I've made more than 5 points there, to be honest. So I'm kind of hoping that's enough. I feel like these first two are probably necessary. This description that you get repeated maxima and minima is almost certainly necessary. This one maybe not so much talking about the center, but definitely we want to make reference to destructive interference and probably back that up with discussion of path difference and constructive interference, and again some reference to path difference I think are probably the 5 marks. So I would guess that, and that. But so you can maybe shorten that answer a little bit. Okay. Part B, calculate the wavelength of the microwaves from the data. So we've got the slit separation, we've got the distance to the screen, and we've got the distance between the central maximum and the first. Double slit formula. This is not a diffraction grating, so we do want the approximate double slit formula. This is A, this is D, this is Y. So plug them all in. For me personally, questions like this, I'll just always put everything in meters. Arguably, if you keep the units consistent, it doesn't really matter. So if I kept everything in centimeters, I would get an answer in centimeters. But in this case, they're all given in centimeters, so it would be absolutely fine to do that. But I'm kind of lazy. I don't want to have to think about that stuff. So I generally stick with just always putting stuff into the basic unit when I see centimeters, millimeters, milliseconds, or whatever. And then I don't really have to think about it. So I've got 0.0312 meters or 3.1 centimeters. Okay, no problem there. This is pretty standard stuff, isn't it? I hope. Reggie has 2 microwave sources, believes he can reproduce the results with the following setup. Okay, so same distance apart. Each source has its own internal signal generator different from the other. So Charlie reckons this isn't going to work because the sources are different, and he's right. There's only 1 mark for this. So really the important thing here is this. The signals are going to be different. We need coherent sources. So these sources will not be coherent and therefore not produce. They're not going to produce a stable interference pattern. My strong suspicion here is that what they're testing for this mark is your understanding that sources must be coherent. So I reckon just not coherent might even get you the marks here. Hard to, I would never, and I wouldn't advocate risking that in an actual exam. But that's the point to be made here, isn't it? So Charlie is correct. Okay, that's it.